Good morning, everyone. Thank you for being here. My name is Jari Liu, and today I'm excited to present our research, revisiting epistemic markers in confidence estimation. Can markers accurately reflect large language models' uncertainty? So, let's start with the basics. What are epistemic markers? They are the words and phrases we use, like clearly, undoubtedly, and fairly certain, to signal our level of certainty about a claim. As large language models become more integrated into our lives, it's crucial to understand how they use these markers to express their own uncertainty. This brings us to our motivation. While epistemic markers are essential for an LLM to communicate uncertainty, how do we know if we can trust them? Current evaluation methods often fall short. They might use another LLM as a judge, which introduces significant bias, or they might just focus on whether the language sounds natural to humans. We identified a crucial underexplored dimension, which is self-consistency. Can a model use the same marker to mean the same thing in different situations? Our research addresses this gap, and our central finding is a bit concerning. The epistemic markers used by LLMs lack self-consistency, which ultimately makes them unreliable. To do this, we first had to formalize what we mean by marker confidence. Our definition is purely empirical. We take a marker, say fairly certain, and look at all the times the model used it in its answers. The marker's confidence is simply the percentage of those answers that were correct. As you can see in the example, if fairly certain was used 31 times and 20 of those answers were correct, the marker confidence is 64.52%. This data-driven approach allows us to objectively measure a marker's reliability. And we developed 7 metrics to get a complete picture. I-average ECE and C-average ECE measure calibration error, telling us how well the marker confidence matches the model's true accuracy, both within a single domain and across different domains. MAC, the marker accuracy correlation, checks if markers with higher confidence values actually correspond to more accurate answers. MRC, the marker ranking correlation. It measures the order of markers from least to the most confident. Stays the same across different datasets. We want this to close to 1. And finally, I-average CV and C-average CV, which measure the dispersion of the confidence scores, telling us if the model is stable or erratic in its marker usage. Now for the results. Table 1 shows a clear trend across all models. The in-domain error I-average ECE is consistently low. However, the cross-domain error C-average ECE is much higher. This means that the model confidence does well within the same distribution and does not generate well in different distributions. And furthermore, the low MRC scores are striking. This shows that the relative ranking of markers is not stable. We do know that stronger models like GPT-4o show better consistency, but the problem persists. And Table 2 confirms that these findings hold even when we adjust our filtering threshold, which shows that our conclusions are robust. These are the findings we have presented. We also made visualizations to show the problem. The heat map shows the confidence value of different markers across datasets for GPT-4o and Qianwen. You can see that the colors representing confidence are over the map. This scatter plot also shows that the normalized ranking of markers is extremely unstable across different contexts. So, why is this happening? Our analysis points to 2 main factors. First, distribution diversity. We found that datasets covering multiple domains like MMLU, Strategy QA show worse calibration performance than single domain datasets like math datasets like GMS Bucket or medical. Second is the difficulty gap. The model perception of uncertainty is heavily influenced by the difficulty of the question. And our study has limitations. We only analyze English, and this behavior could differ across languages. We were also limited by resources, and we cannot test the largest 70 billion parameter models. In conclusion, our work demonstrates a significant issue in how the current LLMs express uncertainty. The use of epistemic markers is not self-consistent across domains and difficulty levels. For future work, developing methods to improve this consistency is a critical area of research. Thank you for listening, and feel free to contact me via email if you have any questions, and I'm open to any collaborations.